So we're going to learn 2 units for concentration. The first one is mass percent. So this one is more commonly used in industry or in medicine. Like if you get a solution, you have an IV drip, it'll give you the concentration in percent by mass. This one's less commonly used by chemists. So this one, the equation's right here. It's the mass of the solute divided by the mass of the solution. And because it's presented as a percentage, we multiply by 100. The mass of the solution would be the mass of any solutes plus the mass of the solvent. Now you can do these calculations for multiple solutes. Pretty sure the AL assignment has you just doing it for ones with one solute. So we're going to do 2 examples. The first one, we're just finding the mass percent. And then in the second one, we can figure out the mass of the solute and the solvent if we know the percent by mass of the solution. All right, so let's look at our first one. So we're going to find the mass percent of sodium hydroxide, dissolving 8 grams of sodium hydroxide in 50 grams of water. So I read this problem out because we need to first identify which is the solute. So the solute is always the smaller amount in the solution. So 8 is smaller than 50. That means that NaOH, that is your solute. And that means that water is the solvent, because that's the larger part of the solution. So first thing we need to do is add up the mass of the solution. So I'm going to do M, SLN for solution. And that's going to be 50.0 plus 8.00. Keep those zeros, those are sig figs. Our addition rule says we go to the least known place value, which would be the tenths. So that's 58.0. All right, so that's the mass of our solution. To find the percent, it's going to be the mass of the solute, which is our NaOH. That's the 8 grams. Divided by the mass of the solution, which we just added together. Times 100, so it's a percentage. And because both of these masses have 3 sig figs, your answer will as well. And that would be 13.8%. And we write the name of the solute at the end. So what that means is that just under 14% of the solution mass comes from sodium hydroxide. All right, so that's solving mass percent equations for finding the concentration. Biggest problem people run into with these ones is that they don't add together the mass of the solution. They put the mass of the solvent on the bottom, because that's what we'll do for molarity. Just remember it's the total mass at the bottom, not just the mass of the solute. Okay, so for our second one, we're going to find the mass of potassium chloride and water. We've got a 5% solution of calcium chloride. That means that that's our solute. And for this one, the easiest way is to use the total mass, solve for the mass of the solute, and then we can just subtract to find the mass of water. So depending on how you do your math, you can either rewrite the whole equation, or you can convert this back to a decimal. So either you start by just writing 5% equals the one we don't know, call X, that's the mass of the solute, over 250 times 100. And then the first thing you do is divide by 100 anyway. So if you recognize that 5% is 0.05, you get to skip that step. Up to you. All right, so 0.05 is equal to 250, or X divided by 250. Then we want to get mass of the solute by itself, so we multiply by 250 on both sides. Cross those out. And with this one, technically we should only have one sig fig. So I'm going to do two answers. So x is either 12.5 for keeping all the sig figs from the calculator, grams, and that's KCl. Technically 1 is best, so 10 grams. And then if we're using 12.5, so the mass of water is the difference. So we do 250 minus the mass of KCl. So if we use 12.5, 250 minus 12.5 equals 237.5 grams of water, or 250 minus 10 equals 240. And this one, I mean, technically they both round to 240. So these are the better answers. All right, this one you could also solve. So we solved for the top. You could also solve for the mass of the solution. You're going to get all the numbers except for the one you don't know. But that is percent by mass or mass percent, our first unit of concentration.